We now want to move into some operations on rational expressions. And the first thing we're going to talk about is multiplying and dividing rational expressions. So this right here is the process for multiplying rational expressions. The way you're going to start this problem is just like how we simplified rational expressions. You're going to factor all the numerator and denominators completely. This is the key. All right, factoring is the key. Okay. Then what you're going to do is you're going to divide the numerator and denominator by common factors. What really is going to go on here is you're going to cancel out common factors. Okay, and then what you're going to do next is you're going to multiply the remaining factors in the numerators and multiply the remaining factors in the denominator. So just to recall how you multiply fractions, if you have a over b times c over d, you're just going to multiply across. You're going to go a times c over b times d. All right, so I have some examples here of how you're going to practice this with rational expressions. And remember what I said, the key is to factor correctly initially. All right, so let's try this. Let's multiply x plus 3 divided by x squared minus 4 times x squared minus x minus 6 divided by x squared plus 6x plus 9. Okay, so the first key thing you're going to do is factor. All right, so x plus 3 stays, nothing you could do there. How about x squared minus 4? Well, that is the difference of two squares, so that's going to factor as x plus 2 times x minus 2 times, so now we got a trinomial. Let's play the number game. What two numbers multiply to -6 and sum to -1? Well, that would be -3 and 2. So this is going to factor as x minus 3 times x plus 2. All right, now what two numbers, again here, play the number game. What two numbers multiply to 9, sum to 6? Well, that's x plus 3 times x plus 3. All right, so now cancel out common terms. So I'm just going to rewrite this so you can see this. So this is x plus 3 all divided by x plus 2 times x minus 2 times x minus 3 times x plus 2 all over x plus 3 times x plus 3. Okay, so here's how you're going to cancel. I have an x plus 3 on the top here in the numerator. Cancel with that x plus 3 in the denominator there. Notice I have an x plus 2 and x plus 2. So now just multiply across. The only thing that's left in the numerator is x minus 3. And in the denominator, I have x minus 2 times x plus 3. Boom. So you can see here that the easiest thing here, or what makes this easy, is if you can factor correctly, you're going to notice a bunch of stuff's going to cancel right out, and it's going to make the multiplying pretty easy with what's left. All right, let's try this one. Okay, let's try multiplying x squared minus 25 divided by x squared plus 10x plus 21 times x squared plus 11x plus 24 all over x squared plus 8x plus 15. All right, so you're going to factor. So x squared minus 25, that's the difference of two squares. So that's going to factor as x plus 5 times x minus 5. All right, so what two numbers multiply to 21, sum to 10? That's 7 and 3. So this is going to factor into x plus 7 times x plus 3 times. All right, what two numbers multiply to 24, sum to 11? I think that's 8 and 3. So it's going to be x plus 8 times x minus 3. And then what two numbers multiply to 15? Or plus 3, sorry. I don't know why I said minus 3 there. Sorry about that. What two numbers multiply to 15 and sum to 8? That's 5 and 3. So that's x plus 3, x plus 5. So all right, so now let's start canceling stuff out. I got an x plus 3, x plus 3, x plus 5, x plus 5. Does anything else look like it cancels out? Nope. Nope. So now you're just going to multiply. So you get x minus 5 times x plus 8. Divided by, and then down here, that's all that's left is this x plus 7, x plus 3. All right, pretty straightforward with this second example. Now let's talk about division. All right, so the quotient. So this is dividing rational expression. The quotient of two rational expressions is the product. So you're going to change it to multiplication. So it's going to be the product of the first expression. So you leave the first expression and the multiplicative inverse or reciprocal of the second expression. Okay, so what this is here is if you have A divided by B divided by C divided by D. All right, so the reciprocal is found by interchanging the numerator and the denominator. Okay, so what we're doing here is we find the quotient of two rational expressions by inverting the divisor and multiplying. So I use this saying when you have the division of two fractions, you keep, change, flip. So I'm going to keep this first fraction the same, A over B. You're going to change division to multiplication, and all you're going to do is flip this. Whoop, you flip it. It becomes D over C. So then now you can just multiply. So it's A times D over B times C. So just remember this keep, change, flip. Keep, change, flip. All right, and I promise you, after you see me do a couple of examples, it's pretty straightforward. Okay, so look here. I have this x squared minus 2x plus 1 divided by x plus 3 plus x divided by x squared plus x minus 2 divided by 3x squared plus 3. All right, so first thing you're going to do is you're going to do this keep, change, flip. So you're going to keep this first the same. You're going to change this to multiplication, and you're going to flip this. So this 3x squared plus 3 all over x squared plus x minus 2. And now you're just going to factor and multiply. So you can see here that it's really just this division is really just multiplication here, just with an extra step. So what two numbers multiply to positive 1, sum to negative 2? Well, that's x minus 1 times x minus 1. I'm going to factor out an x here, greatest common factor. So I'm left with x squared plus 1. Over here, I'm going to factor out a 3. I'm left with x squared plus 1. And then what two numbers multiply to negative 2 and sum to 1? Well, that's 2 and 1, 2 and negative 1. So this is going to be x plus 2 times x minus 1. All right, so let's see what cancels. X squared plus 1, there's an x squared plus 1 up there. X minus 1, x minus 1. We got it. I don't think anything else cancels out. So this is x minus 1 times 3. So this is 3 x minus 1 divided by x times x plus 2. So you see here, this division was really just multiplication. You just needed that extra step. You just got to do this keep, change, flip. All right, let's do one more. Let's take x plus 2 divided by x squared plus 5x plus 4 divided by x squared minus 4 all over 2x squared plus 14x plus 20. All right, so keep, change, flip. So I'm going to keep this. I'm going to change this to multiplication, and I'm going to flip. All right, so let's factor now. So here, x plus 2 stays the same. So what two numbers multiply to 4, sum to 5? Well, that's 4 and 1. Here I'm going to factor out a 2. And when I do that, I'm left with x squared plus 7x plus 10. Okay, so it's like what two numbers multiply to 10 and sum to 7? So that's 5 and 2. And then this right here, this is going to factor as the difference of two squares. So this is x plus 2, x minus 2. And wow, you can see here that not much cancels out. And that's okay. Sometimes that'll happen. Just these x plus 2 cancels out. All right, so then you're left with 2 times x plus 2 times x plus 5 all over here x plus 4 times x plus 1 times x minus 2. And that's okay that, you know, a lot of stuff didn't cancel out here. That's, you know, it's all good. And we got it. So you can see here multiplying and dividing is pretty straightforward, but the key, as I've been saying, the key is to factor correctly and then cancel out those like terms. Or cancel out those common factors, excuse me.